Okay, so this is the review for test number 6. So number 1 is to determine when the fractions are undefined for what values of x. So fractions are undefined when the denominators are equal to 0. So my first fraction is 3 over 3x minus 2. So it's undefined when the denominator, 3x minus 2, is equal to 0. So I add 2, I get 3x is equal to 2. Divide by 3, x is equal to 2/3. So the fraction is undefined when x is equal to 2/3, which really means x can't be equal to 2/3, because if I said evaluate the fraction when x is 5, you could do that. I can't say evaluate when x is equal to 2/3, because then it would be undefined. Okay, so let's take a look at the next one, letter B. So my fraction is x squared plus 2x over x squared minus 4. So again, it's undefined when the denominator, it doesn't matter what's in the numerator, it's what's in the denominator. So when x squared minus 4 is equal to 0. So I can factor this. This is x plus 2, x minus 2 equals 0. So it's undefined at x is equal to 2 and x is equal to positive 2. Okay, so let's take a look at letter C. So we have x plus 3 over x squared minus x cubed, x cubed minus 16x. Okay, so again, set the denominator equal to 0. So I can factor out the GCF is x times x 16 equals 0. And then I can factor x squared minus 16, so that is x plus 4, x minus 4 equals 0. Set them equal to 0. So don't forget about this guy here, because that's an x. So x equals 0, x equals negative 4, x is equal to 4. So the fraction is undefined when x is equal to either 0, negative 4, or positive 4. Okay, so let's take a look at D. So I have x squared plus 2x plus 1 divided by x squared minus x minus 6. Again, it's undefined when the denominator is equal to 0. So I have x squared minus x minus 6 equals 0. We will factor this. So I get x minus 3 times x plus 2 equals 0. T-chart. So I get x is equal to positive 3 and x is equal to negative 2. So the fraction is undefined when x is 3 and x is negative 2. Okay, so let's take a look at 2. 2 is to perform the indicated operation and express in simplest form. So we have division. So let me just write this down. So we have x squared minus 13x plus 40 over x minus 8 divided by 45x minus 9x squared over 9x squared minus 54x. All right, so now we can I'll go into factor and do same change flip at the same time. So I'm going to change the division to multiplication and flip the second fraction and factor. So x squared minus 13x plus 40 factors and becomes x minus 8, x minus 5. Over, I cannot factor x minus 8, so I just write it as x minus 8, times, so this now goes into the numerator. So the GCF of 9x squared minus 54x is 9x, times x minus 6 over, in the numerator, the GCF is 9x times, I'm sorry, I forgot the x there, times 5 minus x. All right, so now we can reduce. So x minus 8 and x minus 8 reduce to 1 and 1. X minus 5 and 5 minus x reduce to negative 1. 9 and 9 reduce to 1 and 1. X and x reduce to 1 and 1. X minus 6 does not reduce with anything. So in the numerator, I have negative 1 times x minus 6. In the denominator, it's just 1. So that would be my final answer. Okay, so let's take a look at B. So B is x squared minus 16 over negative 2x cubed minus 10x squared minus 8x divided by 3x squared minus 11x minus 4 over 18x to the third plus 6x squared. Okay, so x squared minus 16 factors and becomes x plus 4x minus 4. In the denominator here, there is a GCF. I'm going to factor out negative 2x, and then we'll see what's left. So negative 2x times x squared plus 5x plus 4. So that is factorable, so I could do the, factor that again. So let me just rewrite this. I have x plus 4, x minus 4 over negative 2x times x plus 4, x plus 1, times, so this goes in the numerator, GCF is 6x squared, times 3x plus 1. In the denominator, I can factor that trinomial. So that becomes 3x plus 1 times x minus 4. And now I can reduce. So x plus 4 and x plus 4 reduce to 1 and 1. X minus 4 and x minus 4 reduce to 1 and 1. 6 and 2 reduce to 1 and 3. X squared and x reduce to 1 and x. And 3x plus 1 and 3x plus 1 reduce to 1 and 1. Okay, so let's see what's left as our final answer. So in the numerator, I have a 3x. In the denominator, don't forget about that negative, so I'm going to put it right with the bar. And I also have x plus 1. So it's negative 3x over x plus 1. All right, so let's take a look at the next one. That's number 3. Number 3 is to rationalize the denominator. So we have 4 over 3 plus I. When you have a binomial in the denominator, you multiply by the conjugate, which is going to be 3 minus I. So distribute the numerator. I get 12 minus 4I. In the denominator, going to double distribute. So I get 9 minus 3I plus 3I minus I squared. So negative 3i and positive 3i cancel. So the minus I squared becomes plus 1. So it's 12 minus 4i over 10. And now you're going to make a heart and reduce. What goes into 12, 4, and 10? That would be 2. 2 goes into 12 6 times, into 4 twice, and into 10 5 times. So it's 6 minus 2i over 5. All right, so let's take a look at B. So B is 10 over 3 minus 5i. So I multiply by the conjugate. 3 plus 5i. 3 plus 5i. So I distribute in the numerator. So I get 30 plus 50i over, double distribute in the denominator. So I get 9 minus 15i plus 15i minus 25i squared. So negative 15i and 15i cancel. So negative 25i squared becomes positive 25. So I have 30 plus 50i divided by 9 plus 25 is 34. Okay, so now I make a heart, see if I can reduce. Everything's divisible by 2. 2 goes into 30 15 times, into 50, 25 times, and into 34 17 times. So it's 15 plus 25i over 17. Okay, so let's take a look at number 4. Okay, so number 4 is to describe the transformation that maps f of x So we're mapping f of x to g of x. And my f of x, so this is my parent function, is x squared. So let's take a look at the first g of x, which is g of x equals negative 3x plus 4 squared minus 5. All right, so make sure you follow order of operations. So we start inside the parentheses first. Start with multiplication because multiplication is for addition. So when I multiply by 3, that's a dilation. So I'm making it bigger. That is a stretch of 3. And then I go to the plus 4. Now I'm adding 4. I'm adding the 4 to x. That means it has to move along the x-axis. It goes opposite the way you think it goes. So a positive 4 means to go to the left, 4. Now I go to the outside, and I notice that on the outside I have this negative. A negative on the outside, or a negative in general, means that there's some type of reflection. Since I have a negative to my parentheses, my function, that's changing your y value. When you change y to its opposite, that means it's a reflection over the x-axis. And then I have this here, this minus 5 to my function. That means it's moving up or down. I'm changing my y value. So this moves it down 5 units. Okay, so let's take a look at B. Okay, so g of x for B is equal to negative 1/2 x minus 1 squared plus 3. Okay, so same thing, we're going to start inside the parentheses because we follow order of operations. So inside the parentheses, I have to do this here first. So now they're two separate things. It's not a dilation of negative 1/2. One is a reflection and the other one's a dilation. So you do the reflection first. I'm changing x to its opposite. That's a reflection over the y-axis. And now I do the dilation of 1/2. So since I'm dilating by 1/2, that's a shrink of 1/2. And then I'm minusing 1. That's to the right one. It goes opposite when you do something to x. And up 3, because I'm adding 3 to y. Okay, so let's take a look at 5. Okay, so 5 is to perform the indicated operation. So we have 2x squared plus 5x. Over 9 minus x squared minus x squared plus 2x plus 18 over 9 minus x squared. So I'm subtracting fractions. The denominators are the same, which is good. So I know my denominator is going to be 9 minus x squared. You have to be careful because we are subtracting, so you have to make sure you distribute. So in the first fraction, I'll have 2x squared plus 5x minus x squared. I'm distributing the negative, minus 2x minus 8. Combine like terms. So 2x squared minus x squared is x squared. 5x minus 2x is positive 3x. And then I have minus 18. Sorry, I forgot the 18 here. So then it's minus 18 over 9 minus x squared. So now we need to factor. So the numerator factors and becomes x plus 6, x minus 3. And the denominator factors to 3 plus x, 3 minus x. So I can reduce x minus 3 and 3 minus x reduced to negative 1. So my answer is negative x plus 6 over 3 plus x. Okay, so let's take a look at letter B, sorry. Okay, so letter B is, we have different denominators. I have 1 over x plus 1 plus x over x minus 6 minus 5x minus 2 over x squared minus 5x minus 6. So what I want to do is I want to factor that trinomial. So this trinomial factors and becomes x minus 6, x plus 1. All right, so I need to get the denominators the same. So I'm going to multiply the first fraction by x minus 6. And I'm going to multiply the second fraction by x plus 1. And also, when I perform this operation, I have to distribute the negative 1. Okay, so let's see what we have here. I have 1 times x minus 6 plus x times x plus 1 minus 5x minus 2 all over x minus 6 times x plus 1. All right, so I'm going to distribute the 1. I get x minus 6. Distribute the x, I get x squared plus x. Distribute the negative, I get negative 5x plus 2 over x minus 6x plus 1. We'll combine like terms. So I have x squared, x minus 5x is negative 4x, plus x is negative 3x. And then I have, let's see here, negative 6 plus 2 is negative 4 over x minus 6x plus 1. So the numerator factors, and the numerator factors and becomes x minus 4 times x plus 1 over x minus 6 times x plus 1. X plus 1 and x plus 1 reduce to 1 and 1. So I have x minus 4 over x minus 6. Okay, so let's take a look at number 6. Okay, so number 6 is to, given the rational equation, you want to determine vertical asymptotes, any holes, the coordinate of the hole, horizontal asymptote, slant asymptote, and if any of them don't exist, write DNE for does not exist. All right, so f of x, this is A, is equal to x squared plus x minus 2 over 2x squared minus 8. So I notice that I can factor the numerator and the denominator. So the numerator factors and becomes x plus 2 times x minus 1 over, and I could factor out the 2. When I factor out the 2, I'll be left with x squared minus 4, so I could factor that. So it's 2 times x plus 2, x minus 2. All right, so then I see I have the same here. So that's my whole. I'm just going to rewrite my function, the cleaned up form of the function. That's f of x equals x minus 1 over 2 times x minus 2. Or x minus 1 over 2x minus 4. Same thing. All right, so let's talk about our vertical asymptote. Our vertical asymptote is now when the denominator is equal to 0. So 2x minus 4 equals 0. Add 4, 2x equals 4. X equals 2 is my vertical asymptote. So now I have to get the whole. The whole is here at x equals negative 2. So you have to plug negative 2 into the cleaned up version, so f of negative 2, into the cleaned up version to find the y coordinate. So it's negative 2 minus 1 over 2 times negative 2 minus 4. So that's negative 3 over negative 8. So the whole is at negative 2 comma 3/8. All right, so now I need my horizontal asymptote. So I compare the degrees. So you could look at the cleaned up version, the non-cleaned up version. It doesn't matter. X squared over 2x squared. The numerator degree is equal to the denominator degree. So it's like they cancel. So I'm left with y equals the ratio of the coefficients. So that's 1/2. Y equals 1/2. And then the last one is my slant asymptote. There is no slant asymptote when the degrees are the same. So we just write does not exist. So if you have a horizontal asymptote, you don't have a slant asymptote. You can only have a slant asymptote when there is no horizontal asymptote. Okay, so let's take a look at letter B. Okay, so B is f of x is equal to 3x squared plus 5x minus 2 over x minus 1. Okay, so the numerator does factor. The numerator factors and becomes 3x minus 1 times x plus 2 over x minus 1. So I notice that nothing reduces. There's no factors that are the same, so that means I do not have a hole in the graph. So let's start our vertical asymptote. So I don't need to look at this anymore. I could just look at the original. So I have my vertical asymptote is when the denominator equals 0. So I get x is equal to 1. So now let's talk about our the whole. I just said there is no whole. Whole does not exist. And let's talk about our horizontal asymptote. So we compare the degree in the numerator to the degree in the denominator. So when the degree in the numerator is greater than the degree in the denominator, it does not exist. And now let's talk about our slant asymptote. So our slant asymptote is we do long division. So I'm going to do x minus 1 divided into 3x squared plus 5x minus 2. So I get x times what is 3x squared is 3x. Multiply down. That's 3x squared minus 3x. So make sure you subtract. So this becomes plus minus plus. So then I get 8x minus 2. X times 8 is 8x. So multiply down. I get 8x minus 8. And the 8's reduced. So I have plus minus plus. So I get 6. And my remainder is 6. Not that I really even need that. I just need this here. So my slant asymptote is y equals 3x plus 8. Okay, so let's take a look at number 7. Okay, so number 7 is the complex fraction. So number 7 is 2 over x minus 2 plus 1 over x plus 2 divided by 6 over x squared minus 4. So I'm going to just rewrite this to start off. 2 over x minus 2 plus 1 over x plus 2 divided by 6 over x squared minus 4. All right, so now in order to do same change flip, we have to have one fraction here. This one's okay. The second one's fine. This one here I have to add with unlike denominator. So I'm going to multiply the first fraction by x plus 2 and the second fraction by x minus 2. All right, so in the numerator, I have 2 times x plus 2 plus 1 times x minus 2 over x minus 2, x plus 2. So I get 2x plus 4 plus x minus 2 over x minus 2, x plus 2. So in the numerator, I need to combine like terms. So I get 3x plus 2 over x plus 2, x minus 2. And now I can bring this guy down. 6 over x squared minus 4. Okay, so now I can do same change flip and factor. So 3x plus 2 is not factorable, so it's just 3x plus 2. X plus 2, x minus 2, that's already in factored form, times x squared minus 4 becomes x plus 2x minus 2 over 6. So I have x plus 2 and x plus 2 reduced to 1 and 1, x minus 2 reduced to 1 and 1. So my answer is 3x plus 2 over 6. All right, let's take a look at B. Okay, so B is 1 over x squared minus 1 all over 1 plus 1 over x. So I'm just going to rewrite it right now. So it's 1 over x squared minus 1 divided by 1 plus 1 over x. All right, so in both parentheses, I have to get the same denominator. So I'm going to multiply the right one over here by x squared. So I get 1 minus x squared over x squared. And I'm going to multiply this one over here just by x. So I get x plus 1 over x. Now I can do same change flip and factor. So 1 minus x squared is 1 plus x, 1 minus x over x squared times x over, I cannot factor x plus 1. Now we can reduce. So 1 plus x and x plus 1, they are the same thing. They reduce to 1 and 1. 1 minus x does not reduce, but x and x squared reduce to x and 1. So my answer is 1 minus x over x. All right, so let's take a look at the last one, number 8. Okay, so number 8 is to write the polynomial functions whose zeros are, and for the first one, My zeros are 0 and plus minus 2i. Okay, so I'm going to set them equal to 0, x. So x equals 0 and x is equal to plus minus 2i. So this guy over here is fine. I'm going to work on the right side over here. So to get rid of the I, I'm going to square both sides. So I square the right side and I square the left side. So I get x squared equals, when you square plus minus, it just becomes plus, 4i squared. 4i squared becomes negative 4. So I add 4 to both sides and I get x squared plus 4 equals 0. All right, so now I have to take x and multiply that by x squared plus 4. So I have x cubed plus 4x equals 0. It has to be equal to 0, or you have to equal it to f of x. One of those. If you don't, I'll take off of that. All right, so let's take a look at the last one. Okay, so for the last one, my zeros are negative 3 and 1. I know it says plus 2i, so you have to know it's plus minus 2i. So I have 3 zeros here. One of my zeros is x equals negative 3. So my factor is x plus 3 equals 0. Now, on the last test, some of you guys, I don't know, for some reason, separated this here and made one of the zeros 1 and wrote x equals 1 and then wrote x is equal to 2i. That is not correct. Okay, you have 2 zeros here. Your zeros are x equals 1 plus minus 2i. So then I'm going to subtract 1. I get x minus 1 equals plus minus 2i. And then to get rid of the plus minus 2i, I'm going to square both sides. So I square x minus 1. And that becomes x minus 1 times x minus 1 equals, when I square this guy here, I get positive 4i squared, which then this becomes negative 4. So on the left side, I get x squared minus 2x plus 1, and I add 4, I get x squared minus 2x plus 5 equals 0. So now I have to take the x plus 3 and the x squared minus 2x plus 5, and I need to multiply them together. All right, so I have 3 times 5 is positive 15. 3 times negative 2x is negative 6x, and 3 times x squared is 3x squared. And now I'm going to multiply the x. Times 5 is positive 5x. X times negative 2x is negative 2x squared, and x times x squared is x to the third. We add them straight down. I get x to the third plus x squared minus x plus 15, and that has to equal either 0, or you have to have f of x equals x cubed plus x squared minus x plus 15. Okay, so that's it, and study, study, study. Have a good night.